The Sustainable Localized Food and Education Systems EPICS and IEEE project at Rowan University aims to create a modular water system for raised garden beds, microgreen hydroponic units, a series of aerial drones for seeding, monitoring, harvesting, and a simple system for food preservation and refrigeration for the students of Rowan University. In addition, the student team will be engaging with local high schools to teach K-12 students about STEM.
Hi, I'm Abby Riley, and I'm a senior ECE major.
I'm Sahir. I'm a fourth-year mechanical engineering student.
I'm Mason Posner. I'm a senior mechanical engineering major, and this is our project, an IoT automated watering system. The whole goal of this system is for it to be completely automated with different sensors in the soil that will tell the Raspberry Pi controlling the entire thing when to shoot water, when to send notifications to the gardeners to, if they have to do anything, if they have to fill up the rain barrel, or if there's something wrong with the plants. The one major issue with our prototyping is that the only water source available is over there by that building, and we can't run hoses and other electronics across the sidewalk. That was one of the main things that facilities told us we couldn't do. And same thing with the solar panel, and we have a solar battery in there that it charges. The whole reason behind that too is that the only electrical outlet out here is also over there.
Hi, I'm Jason Blanda. I'm a junior ECE here, and our system is one large Internet of Things system controlled by a Raspberry Pi with inputs of sensors and outputs of pumps and solenoid valves that will tell the system to turn on and off. The valves will open, the pump will turn on, and water will run through the system. The way that it works is our moisture sensors will tell us when a certain threshold moisture level is met. When below that threshold, the system will turn on, water the garden until the threshold's met, in which case it will turn off. Also, we have water level sensor inside our barrel that will tell us when the water level is too low.
Hi, my name is Gianna Cava. I'm a junior engineering entrepreneurship major. So for the automatic irrigation system that we went with a soaker hose, and instead of watering it all at once, and previously they were just using watering cans and going individually to each plant, we chose the soaker line because it'll slowly drip and leak out along all of the plants, so we'll actually just run it right next to the root of everything that they plant, and it'll slowly leak out. It's a lot less wasteful with the water, and it allows them to have a lot more control.
Hi, my name is Mariana. I am the Community Garden Chair. So Rowan Environmental Action League is the student organization that hosts the community garden. Everything grown here is edible foods. The main purpose of the garden is to provide food for students. At Rowan University, there was a study done called the SHOCK Survey, Students' Hunger on Campus, that found up to 49% of students experience food insecurity. Food insecurity means that you don't know where your next meal is coming from. So everything we grow here, we grow from the feedback of students, what they want to see. Right now we have carrots in the ground. Right here there's a raspberry bush. Right behind me there's strawberry plants.
Hi, my name is Jack Thorpe. I'm a junior engineering entrepreneurship student, and this project helped me get my internship this summer. So I was able to use this project to get an internship for the summer because this is something that I've never worked on before, so something I had to research on my own and learn about and then be able to make it a reality. And that was able to show that I can adapt to different situations and use that for other situations with like the internship.
My career plans for the future, I'm going to be working as a plumbing and fire protection designer for MG Engineering in New York City. That's who I did my internship with, same team doing plumbing and fire protection design, and that's where I'm going to continue to do my career and hopefully get my PE at some point. So some of the soft skills that you learn just by working in a clinic with the group of other engineers is one, just major teamwork and communication skills. Like some of the biggest things that you'll see, especially in your career, is having to work with other people and having to communicate with them outside of obviously just the classroom environment.
Hi, I'm Katie Badias. I am a senior lecturer in the engineering education department here at Rowan University. So the project had multiple deliverables. The one that you saw here is for the Rowan University Environmental Action League, where they actually have a garden on campus. We have two other deliverables, one that does outreach with Legos to elementary school students, and I'm also working with a local high school in the area, Clearview High School, where they're actually developing a drone that could do some seeding and also some harvesting through this IEEE EPICS grant that we received. Some of the learning outcomes that I saw through the students is they actually get a lot of hands-on experience through these projects, as well as working with a community partner.
We're very excited to have the United Engineering Foundation sponsoring our EPICS and IEEE Environmental Competition. This competition paired local groups with faculty members and industry mentors as an opportunity to have local impacts. If you could tell me a little bit more about how the industry mentors had a positive impact on this project in the community.
So, being a chemical engineer, I didn't have all the lingo and all the knowledge that I needed to be able to actually get this project off the ground. So it was really useful to have an industry mentor who could give me the support and knowledge that I needed to actually show the students and give them the experience that they needed in order to be able to get this project rolling.
We want to thank all of our EPICS and IEEE donors who have made projects like this possible in the community. Can you explain what difference this project is having and how EPICS and IEEE funding really made this launch?
So this garden actually didn't have water resources to begin with here. So by having all the rain barrels and the pumps and everything else actually allows this garden to exist and give it more opportunities to thrive and give more to the community in terms of the food resources they have. They also added an extra bed with some of the funding and were able to provide more soil to actually give some more nourishment to the plants that are there. With the other funding sources, we were able to actually expose high school students to a little bit more about drones and provide them some fundamental knowledge about motors and different types of programming using servos and the like. And then also with the outreach, we'll be able to reach younger students. Most of the time, people want to reach out to middle and high school students and do programming and outreach with them, but we're actually going to be reaching out to younger kids so that they also get those experiences earlier on, as opposed to once they already know sort of where they're going with their lives.
Thank you, EPICS and IEEE donors, for your support.